Hello guys. Welcome back to another video. This is Tridenour Science. How big is the universe? How far have the radio waves, broadcasted by humans in search of intelligent life, reached in the universe? What are your thoughts on these questions? Comment below. This is Earth. We live here. Now you are looking at the image taken by William Anders, in Apollo 8 mission of orbiting Moon, at a distance of around 384,400 kilometers from Earth. This image later came to be known as the Earthrise. While exploring the ancient habitable environments of Mars, on January 31, 2014, NASA's Curiosity rover took this image, at a distance of 160 million kilometers away from Earth. Such a small dot in the Martian night sky, isn't it? During its mission of studying one of the fascinating gas giants of the solar system, the planet Saturn and its system. The Cassini spacecraft took this image, where Earth can be seen as a blue dot underneath the magnificent rings of Saturn. When the Voyager 1 spacecraft started its journey in the interstellar space after passing the planets Saturn, Uranus and Neptune, Carl Sagan suggested to take an image of Earth, by rotating the spacecraft, and the image it took was this, at a distance of about 6 billion kilometers.
We live on a mote of dust, suspended in a sunbeam.
As famously quoted by Carl Sagan himself. The Voyager 1 spacecraft, at its current speed, which is 17 kilometers per second, would take roughly 30,000 years to cross the Oort cloud, which is a local cloud of gases and likely, the end of solar system. The technology of broadcasting the radio waves into space was accomplished in the 1900s. Even though these waves travel at the speed of light, that is 299,792.458 kilometers per second, the radio waves broadcasted in 1900s have traveled almost 120 light-years. 1 light-year is the distance traveled by light at the speed of 299,792.458 kilometers per second, in 1 year. 1 light-year in figures will look like this. But this mind-bending distance is just a small dot when compared to the size of our galaxy. As now we know how large a light-year is. Our galaxy is about 105,700 light-years across. This galaxy contains about 100 billion stars and more than 100 billion planets. Moving beyond Milky Way, we reach the local group of galaxies, which is home to a total of 54 galaxies. The center of mass of this group lies somewhere between the Milky Way and Andromeda Galaxy. The local group spans around 10 million light-years. Zooming further out, we reach the Virgo Supercluster, in which the local group is just a tiny part. This supercluster is home to more than 100 groups of galaxies, similar to our local group. The span of Virgo is nearly 110 million light-years across. Moving beyond Virgo Supercluster, we reach the great Laniakea Supercluster, of which the massive Virgo Supercluster is just a tiny lobe. Laniakea is home to nearly 100,000 galaxies. The span of Laniakea is mind-bending 520 million light-years. But even this great supercluster forms an insignificant part of everything we can see. This observable universe has a span of mind-blowing 93 billion light-years in any side. It is home to more than 2 trillion galaxies, and contains more stars than the entire grains of sand on Earth. Now get ready to be blown by what's coming next. This observable universe is just a part of entire universe. The reason we call it observable is that we can't see what lies beyond this, because the light from that part of the universe has not yet reached us. As the universe is expanding at an increasing rate, it is believed that some part of it may not be seen even if mankind existed eternally, as the light from that part may not reach us, because the space expands at the speed of light. The universe beyond could be way more beautiful, and even more massive than the observable universe. According to the cosmic inflation theory, if the universe started expanding at 10 to the power of -37th of a second after the Big Bang, then it suggests that the current size of the entire universe is mind-boggling 150 sextillion times more massive than the observable universe. This number in figures looks like this. To put this into perspective, if the observable universe is the size of a football, then the entire universe would be the size of Earth. We can't even imagine such vastness of the universe, and even consider the fact that the universe is expanding at an increasing rate, and is not aiming to stop. We humans should follow the same thing from the universe and should never stop learning, teaching and growing as a civilization altogether. We must keep exploring everything around us, and ask questions about everything that you explore. So, be curious and imaginative. Thank you for sticking around, and we will be coming back with more fascinating things in the universe for you to learn and be amazed. So stay tuned. Please like and share the video, and subscribe to our YouTube channel to get notified whenever a new video drops. Please follow us on Instagram and Twitter. Up to then, goodbye.